Welcome everybody. Good morning and welcome to the SunHorizon Solar Stakeholder Workshop. I'm Serena Scotton. I'm working at the European Heat Pump Association, which is today's event organizer and is also a VP leader for dissemination communication activities in the SunHorizon project. I'm happy to see many people attending this workshop. This is the first stakeholder workshop that we are organizing in the framework of the SunHorizon project. Maybe not all of you are familiar with the project. SunHorizon is an Horizon 2020 project which aims at developing sun-coupled innovative heat pumps in a residential and tertiary sector. Today, we will focus on the solar technologies involved in the project. In the upcoming months, we will have another workshop dedicated to the heat pumps. Nevertheless, if you are interested after this workshop in the project, you can sign up as a stakeholder. So you will be updated on the relevant and stakeholders activities that we will have in the upcoming months. As well, you can easily register as to receive our newsletter that is sent out every 6 months with general updates on the status of the project and the activities always related to SunHorizon. Coming back to today's workshop, I would like to briefly go through the agenda. We will start with a general presentation of the SunHorizon project given by the coordinator, Alessandra Cuneo. Then we proceed with David, who will present the preliminary results and some data from the demo sites. We will continue with the VP3 presentation by Andrea Frazzica. Then we will focus on the solar technologies, and we will have a presentation of the SunHorizon hybrid PVT solar technology with Jean Marie. Then we will proceed with the presentation of high vacuum solar thermal technology by Guglielmo Cioni. And then we will conclude with 2 external speakers who will provide us relevant presentation about the RINA solar policy with Pedro Dias from Solar Heat Europe, and Daniel Mugnier from, who will present the solar PV and thermal cooling. As you can see, we will keep all the questions raised from the audience for the last 20 minutes. So if you want to submit any question for the speakers during the workshop, please use the questions chat that you have. I'll be the one receiving all your questions and I will moderate them in the Q&A session. So please send a message with your question and always remember to put the name of the speaker that you want to refer your query. Some technical information about the workshop. I remind all speakers to please unmute themselves while they're not speaking. Respect the timing. All the participants will receive the material of this workshop. So it means all the presentations and the video of the workshop recorded tomorrow via email. But you can also find it in the SunHorizon website and social media channels. So this is an overview of our speakers. Now I would like to present the official speaker, first speaker, Alessandra Cuneo, who is also the project coordinator. Alessandra, the floor is yours.
Thank you, Serena, for the introduction, and good morning, everybody. I'm Alessandra Cuneo from RINA Consulting, which is one of the largest engineering company in Italy. I am the project coordinator of SunHorizon project. I will shortly present you the project, the aim and the objective, while then I will leave the floor to my colleague David David Chèze and Andrea Frazzica to present you more details about the demo sites and the technologies involved in the project. So, which is the objective of SunHorizon and aim? So, as most of you know, the buildings are responsible for a very large part of energy consumption in Europe, and especially heating and cooling demand is covering around 50% of the total energy demand. So in order to speed up the transition towards renewable energy sources based on heat and cooling, to cover heat and cooling demand, it's needed to design and develop an innovative solution that can be speed up such transition. And that's what exactly SunHorizon aim to do. So to unlock the potential of user-friendly and cost-effective solution based on optimized design and combination of solar panels and heat pumps. So the aim, since heat pumps and solar appliances are the most socially accepted renewable energy source, is to couple them in several ways that will be presented later to cover the heating and cooling demand. And of course, the project will control such technology packages, so the integration of the different technologies via a data-driven management control platform and a monitoring platform. So during the project, we will not work only on technology levels, but also on a monitoring and control platform that can properly satisfy the energy demand, considering the indoor and thermal comfort of the end users. And so the project started in October 2018, and we just finished the pre-demonstration phase, in which we make a baseline estimation of the demo sites, as well as we sizing the technology packages respecting the needs and the constraints of each demo. And all the technology providers work to improve their technology, increase the performances and reducing the cost. Now we are in the phase of the prototype phase, so all the technology will be tested at the laboratory level, and the technology package will be integrated and tested as well at the laboratory before deployed and installed them in the 8 demo sites involved in the project next year. In the project, we have 6 different technologies based on solar panels, heat pump, and thermal energy storage that will be presented later by Andrea Frazzica. And these 6 different technology will be coupled in different way to satisfy the heating in terms of space heating and domestic hot water and cooling demand in 5 different ways. So integrated the different technologies or in parallel integration or series integration, etc. For what concerns the demo site, the project is a very demonstration to market project, and we aim to perform a very robust and wide demonstration in Europe. The demonstration will cover at least 12 months to cover 1 year of monitoring. And we have different type of buildings, starting from small residential building, large residential building, and tertiary buildings, so office or swimming pool and sports center, to cover as much as possible the different typology of building that we can have in Europe, so to demonstrate the high potential of SunHorizon innovation. And the buildings are located in different countries such as Spain, Germany, and Latvia and Belgium, to cover different climate condition and different contexts, also in terms of markets and needs. And as I mentioned before, one of the aim is related to the development of a cloud-based functional monitoring platform to be a sort of performance data for the development of data-driven optimized algorithms and tools for predictive maintenance to optimize the management of the technologies towards the maximization of the solar exploitation. And of course, some tools will be developed to help the manufacturer towards new installation design to reduce the operational and capital cost. Okay, so this is the consortium. So it's a very industrial-driven consortium in which we have big technology manufacturer as well as energy utility building owners and several RTO institutions that will help in the research activities. So this is just it's the technology roadmap of the project. So we start around TRL 5, 6 of the different key exploitable results that are related to the tools and to the technologies. And the aim is to reach TRL 7 at the end of the project and to have all the solution and innovation ready to the market 1 year after the project ends. So it's very demonstration-driven project towards the marketability of all the solution in a very fast way. So this is a very brief presentation of the project. Of course, a lot of details will be presented later by all the other colleagues from the consortium to give you more details on the demo sites, on the technologies and the preliminary results that we achieved in the first 18 months of the project. So thank you all, and if you have any question, please write on the chat, and I'm glad to answer you at the end of the workshop.
Thank you, Alessandra. Thank you for your presentation. We can now proceed with David. The floor is yours, David.
Yes, good morning, everyone. I think that you can hear me now. So I'm pleased to present you the preliminary results that we had about the central activities in SunHorizon, which is the demonstration of the technologies of the coupling of solar technologies with heat pump technologies for building heating and cooling. So as you can see, and the aim in just one slide is to combine the technology, different heat pump technologies with different solar panels technologies in real demo sites across Europe. Later on, Andrea will give you details about the developments of the several components, heat pumps or solar panels. So it's just a visual view of the combination within the technology package, the whole systems. So this is really joining the strengths from solar panels manufacturers to support and enhance the performance of heat pump components in order to achieve overall increased performance and mainly greenhouse gas savings in Europe. So I will give you a few insights about the several demo cases that have been processed in the last months. First, for the technologies that is combining flat high vacuum solar panels, solar thermal panels from TVP with the heat pump from Boostit, so which is a gas thermal compressor driven heat pump, CO2 heat pump, that is consuming gas and electricity, but it's mainly consuming gas. So it's the main originality of these products. So this will be demonstrated first in a residential building from the beginning of the 20th century in Berlin, in Germany. So you can see in the pictures a very typical building in this area. And for every demo sites, we proceed in the same way by the modeling of the building. So in 3D modeling, detail modeling, dynamic modeling of the building, then we assess the energy baseline of the building, also assuming the energy consumption in terms of heating or cooling demand, the electricity consumptions, and then we add this reflection between the technology providers for solar and heat pump on how to combine themselves into relevant architecture to satisfy the demand, the heat demand, the cooling demand. So that's the results for this residential building in Berlin, where the solar thermal heat is classically preheating domestic hot water or the return line from the radiator of the building in order to substitute the heat demand that is to be covered then by the boosted heat pump. So this is a serial integration on the hot side, on the heat demand side of solar and boosted heat pump. In this site, we combine also the use of the outdoor dry cooler in order to avoid the doubling the cost and the installation time by using two units, because this unit will be used by the heat pump and by the solar panels when there is an excess of solar heat in summer, especially. So we end up with about 36% of greenhouse gas savings from the simulation to the preliminary design simulations that has been performed for this site in Berlin. So for the second demonstration site for this PP1 technologies, we focus on a large tertiary building in Belgium, in Verviers, and it is a sports center with a very high heating demand. It has been modeled as well in 3D model before sketching the integration of the solar technology with the heat pump. Here we will not use we will not utilize the dry cooler because of the integration constraint of the dry cooler to the heat pump, so it will be separate in this case, and also the amount of energy involved is much larger. As you can see, we talk now about 200 meters squared of solar panels integrated on the roof of the sports centers. And in this case, we aim to achieve about 26% of greenhouse gas emission savings thanks to the solar integration with the heat pump. And this system will be integrated in series with the existing gas boilers supplying the heating and domestic hot water. There is a significant amount of energy that has to be dissipated in summer, and this we also performed a study in the case of the owner of the municipality would like to add solar cooling to this plant, because there would be enough solar capacity and also high temperature availability solar heat. In this case, the study was performed, and but it was not anticipated, so it will not be covered by this project. It might be a next steps. Then we have the second technology packages that is combining the solar panels from DualSun, hybrid PVT panels producing heat and electricity, combined with the boosted heat pump. In this case, this technology is we will demonstrate in Riga, in Latvia, so a very northern climates and significant heat demands. This installation, the combination of the solar and heat pump is done here first on the cold side of the heat pump. So the solar heat from the low grade temperature from the PVT collectors will support the efficiency of the boosted heat pump at the evaporator sides. And it can also be used in summer when there is no or low heating demand to heat the second buffer tank that can be used mainly to preheat the domestic hot water. In this site, the electricity, the strategy was to first feed the electricity produced by the panels into the net, the grid, because of tariff incentives in this way, and then when a certain threshold and a certain amount of electricity is fed in, we switch the strategy to store the electricity as heat into the buffer tank, into the hot buffer tank. It is estimated that these systems can save about 41% compared to the previous existing system integrated in this house. This technology package combining hybrid PVT panels from DualSun with the boosted heat pump will also be demonstrated in a tertiary building in Verviers in Belgium in order to sorry, there is yeah. So and it so it's a completely different integration because it will be used not to heat the building, but directly the water from one of the pool, from the small pool of this large swimming pool, and so this is a typical application of the PVT technologies with using its better performance. So most of the heat will be supplied directly on to preheat the water, and it can also support the boosted efficiency when connected to the evaporators. There is a large area integrated in these sites, and the large PV production will be used to cover the large electricity consumption of such a swimming pool, and this ends up with a very high self-consumed rate, about 100%, mainly this electricity is for the ventilation and the humidifying devices that are running all year round in this swimming pool. These technologies will be again demonstrated in a residential building, quite large multi-apartments building in Germany with a cold climate. The integration is close to the first case that I presented in Riga. So the solar heat from the PVT panels will support the efficiency of the heat pumps when running in heating mode, and preheat the domestic hot water on the hot side, especially in summer. In
David,
this case,
sorry to interrupt. I was having also technical issues. Maybe we should be a bit more faster in the presentation, otherwise we don't respect the timing and we will have issues then in the Q&A. So if you can be maybe a little bit more concise, then all the participants will receive all the presentations, and they can also send you an email if they will have further request of information.
Okay.
Thank you. Sorry.
I'll move on. Then the third technologies that is to be demonstrated in Sant Cugat, close to Barcelona. In this case, the high efficiency solar collector from TVP will achieve to drive the Fahrenheit adsorption unit, especially in summer, for the cooling of these large tertiary buildings. And we achieved to cover most of the heating demand, and part of the cooling demand is covered thanks to these architectures, and it ends up with about more than 35% of greenhouse gas emission savings in these cases. And the other technology package that is combining the PVT panels from DualSun with the heat pump from the BDR Thermea company will be demonstrated in Madrid in the multi-apartments buildings with that, and this architecture to provide heat and cooling will enable to save up to 70% of greenhouse gas emissions compared to a conventional solution with only gas heating and small split unit for the cooling in summer. So this is a very high savings that we can achieve with this combination of the solar supported heat pump by the PVT solar panels. And then a variant of this approach that will be demonstrated in a residential building in Spain is combining separate solar PV panels and solar thermal panels with a conventional heat pump from BDR. And here we calculate how to optimize the share of PV and solar thermal panels in order to get the highest savings. So it's 2 panels for solar thermal and 6 panels for PV. And then I will just tell that we have a very large amount of savings that can be achieved thanks to this demonstration, from 30 to 70% across all the sites. So it's a success, and of course I'll be happy to answer some of your questions about the details. Thank you.
Thank you very much, David. Now we can proceed with the third presentation about the work package 3 of SunHorizon. I kindly remind to all speakers to please try to respect the timing so we can have then quite a long Q&A session. Please, Andrea, the floor is yours.
Yeah, can you hear me?
Yes.
Perfect. So good morning, everyone. Yeah, thank you for the introduction, Serena. I will be presenting the work package 3 of SunHorizon, which is about the enabling technologies we are developing within the project. On behalf, I would say, of all the technology providers that are working inside the work package 3. So a very brief overview of the agenda. We'll have, of course, an overview of the work package 3 about the main aims of this activity, and then I will really briefly present the enabling technologies that are proposed inside the project and the innovations that we are currently introducing to make them more efficient and, let's say, better suitable for including in the technology package that have been already presented by David. And finally, very briefly, the future activities that we foresee in the coming months. So I would say this slide was basically already presented by Alessandra, and as we already introduced, the main aim of SunHorizon is to deploy 4 technology packages that will be tested in 8 demo sites all around Europe. We'll have also a 5th technology package that will be basically only simulated out of the experimental results that will be, let's say, achieved during the testing phase, both at demo site level and in the lab. So as I told you, the main aim of this presentation will be to present each single technology that will be, let's say, part of this activity. Which are, let's say, the objectives of the work package 3. It is, I would say, the first pillar of the SunHorizon concept, because it's about the further development and optimization of these proposed enabling technologies. I would say that we have a quite well balanced portfolio of technologies in terms of, let's say, TRL, because we have quite, let's say, standard or established technologies already on the market, like heat pumps or stratified thermal energy storage. But we also have some technologies that are already on the market, but I would say in an early phase, and that are, let's say, strongly developed during the project to be really applicable for the SunHorizon technology packages. Accordingly, we are basically developing these technologies, mainly driven by the main features of the technology packages, in order to make these technologies suitable for being integrated in these new technology packages. And of course, part of this work package is about the final design of these enabling technologies that will be then, of course, tested at lab level before being installed in the demo sites, and will be also, let's say, providing manual for proper installation, specifically as, let's say, defined for the single technology package that we are aiming at. Yeah, the overview is this one. Basically, we have in the work package 3, we have 7 technology tasks running more or less in parallel, which are focusing on each single technology, and the last one, which will be, let's say, the task that will focus on the validation of each technology at lab level. Starting from the first technology we have inside SunHorizon, as I told you, this is an example of let's say a technology already on the market, but in a very early stage, is the boosted gas-driven compression heat pump. It is not like a standard gas-driven sorption heat pump, which is more established on the market. This is a real compression cycle, which is working out of CO2 as working fluid, so very extremely low GWP, basically 1 is GWP. But the main innovation is, in this case, we are not providing any mechanical work out of electricity to run the compression cycle. And as you can see here, it is based on this patented gas-driven process, which is, I cannot go in details, but is, I would say, close to an internal combustion engine. So it's exploiting the difference in temperature of 2 points of the cycle to provide the thermal compression. On the market, we have a 20 kilowatt machine, which is right now as a standard component an air-sourced heat pump, which is providing very high gas utilization efficiency, especially if we compare against the, let's say, the main competitor with gas, which is of course a condensing boiler. We can achieve up to 197% of gas utilization efficiency when we have 10 degrees C on the evaporator side, but the maximum efficiency can be reached down to minus 22 degrees C outside temperature, of course. The second technology, of course, I will try to focus a little bit. Sorry. Okay. I will try to focus a little bit more on the heat pump technology, since you will have the deep presentation of DualSun and TVP about the solar technologies. The second one is about the hybrid sorption compression chiller that will be developed by Fahrenheit, which is a German company. Basically, this technology is integrating vapor compression cycle with absorption one, so a thermally driven one. And within the project, one of the main tasks is to further develop the absorption part of the chiller, which will be based on innovative zeolite materials that are more suitable for being applied in a quite hot climate, like the Mediterranean one, in which the technology bagel will be installed. And the second task is about optimizing the integration of the vapor compression with the absorption machine. There are different possible options, so like pre-cooling, parallel integration, or even cascade one. In the case of SunHorizon, together with Fahrenheit, we selected the parallel integration, so we'll have both machines working in parallel. Of course, the prioritized one will be the absorption one, which will be driven by the solar heat provided by TVP Solar thermal collectors, and the vapor compression machine will be, let's say, integrating the cooling capacity needed by the machine. The third technology inside SunHorizon, sorry, is the provided by BDR Thermea. As I told you, this is an example of one of the technologies that are more established on the market. Is since we are basically providing a vapor compression heat pump. So the main activity that will be presented later on is about the optimization of the integration of this technology with solar thermal provision. That's why inside the project we'll make use both of water-to-water heat pump when we aim at exploiting the solar thermal as let's say heat source for the evaporator. But we'll also include air sourced heat pump in some of the technology packages to increase the flexibility of the system, as you can see here for the technology package that will be installed in the SunHorizon demo site. The fourth technology, as I told you, will be more in detail presented later on by the colleagues from DualSun, but it is the first solar technology presented in SunHorizon. It is actually an hybrid PV technology, so we are providing both photovoltaic, so electrical and thermal energy. It can be, let's say, adapted both to maximize, of course, the PV production or the solar thermal, so up to provision of domestic hot water. And inside the project, it will be presented by the colleagues. It will be mainly coupled to heat pumps to support their evaporation heat. The fifth technology is again a solar thermal one. It is provided by TVP Solar. Again, we'll have a presentation by Guglielmo later on, more in details about the technology. But the main innovation in this case is that this represents the first solar thermal technology on the market based on vacuum flat plate solar thermal collector. It is already on the market, the technology, but it was mostly focused on industrial application, since it can reach up to 180 degrees C as output. While inside SunHorizon, the main task will be to, let's say, redesign the technology to be optimized for lower operating temperature, so for domestic or tertiary buildings. And of course, reducing the capital cost of the technology to make it suitable for domestic application. But the main feature is that the efficiency of this technology is much higher than the standard one, as you can see from the graph reported here. And the last enabling technology of SunHorizon that will be further developed within work page 3 is the ratio one, so sensible storage tank, stratified storage tank that will be included, of course, in all the technology packages, since it is a critical component to properly couple both solar, thermal, and heat pump technologies. It is, of course, one of the most established technology on the market, but inside the project, as we'll see later on, we are developing a new stratified components to optimize the stratification, also considering the large-scale tank that will be deployed in some of the demo sites. Here, really briefly, some insights about the development activities that were performed so far inside the project. Basically, for boosted heat pump, the first activity was focused on optimizing the control and the monitoring of the boosted 20, which is the standard on the market, especially integrating, let's say, water-to-water heat exchanger to let the evaporator being supported by the solar thermal collectors. Furthermore, they also, the colleagues from Boosted also redesigned the structure of the Boosted in order to make the indoor installation easier compared to the standard machine currently on the market. Regarding the hybrid Fahrenheit machine development, as I told you before, is more on the component side, especially the optimization of the main components, so the adsorber and the evaporator condenser from the adsorption machine, and also the basically the integration of the vapor compression machine, especially inside SunHorizon. Fahrenheit decided to go for a low GWP natural refrigerant, so R290, which will be manufactured and installed in parallel to the adsorption machine for the application in the San Cugat demo site. While, as I already anticipated, BDR Intermea, so the heat pump, especially the water-to-water heat pump, is being, let's say, adapted, especially from the control strategy point of view, to be properly integrated with the solar thermal source to operate at higher temperature than the standard that are expected by the standard machine on the market, and also to let's say optimize the hydraulic integration between the components. Regarding DualSun, and basically there were a lot of activities ongoing, but the most relevant ones were dedicated to the design of a simplified hydraulic connection, which can reduce the time for installation and so also the space required. It was supported by both theoretical and experimental activities, and also to reduce the cost and the weight of this panel. They also developed a thinner structure for supporting both PV and thermal collectors together, so to realize a lighter solution. While on TVP Solar side, they developed new coatings deposited over the aluminum flat plate, and also they try to redesign the exit ports of these solar collectors to let's say improve the thermofluid dynamic performance. And I guess they will also give more details about the further development they expect to do. While, as I told you, Ratioderm was mainly focusing on an innovative and low-cost certification device that can be, let's say, suitable, especially for the large-scale thermal energy storage that we will install in the technology package. And finally, which are the future activities? Basically, of course, due to the coronavirus situation, we had a slowdown of the activities in the last 6 months, but basically, we are now going to finalize the innovative design of each component and each technology. And the next step within work package 3 will be the lab scale validation of each single technology at CEA and CNR labs, as well as some of the technology packages that will be installed at CEA before being deployed to the demo sites. And once this activity will be completed, then we'll go for the definition of the installation guidelines and realization, installation, validation, and commissioning of the technologies in the 8 demo sites. So thank you for the attention.
Thank you, Andrea, for your presentation. We can now continue with the second session dedicated to dedicated to the solar technologies, and the next presentation will be about DualSun. Jean Marie, now I'm giving you the control.
Good morning, everyone.
Good morning. The floor is yours, please.
Okay, perfect. Thank you. So yeah, I'm Jean Marie Drap from DualSun. I'm in charge of the business development of the company, and I will introduce you the company and what we achieved. Okay, that's working. Yeah. Okay. So we started in 2010 with 2 observations. one solution. First, the photovoltaic and thermal solar panels were limited technologies. So, for example, for the photovoltaic panels, the efficiency is only 20%, and you lose a lot of efficiency when they get hot in the sun. And the solar thermal panels have a overheat problem during summer. So we try to bring a solution with a heat exchanger on the back of a standard PV panel to cool down the cells and improve the efficiency of the cells, and to avoid overheating during summer. So that's the hybrid panel. So it was the first one certified in the world. We worked a lot with the TÜV in Germany to do that. And why this is useful for the buildings is all buildings need some electricity, space heating, and hot water. So you need both energy on each roof. So that's why we worked a lot to bring this solution. So this is a hybrid solar panel made in France. You can see the PV cells on the top of the panel, and then on the back you have a heat exchanger in polypropylene. And thanks to that, we can produce two energy with the same area, same surface of panel. We have a 10 years warranty product and labor costs, and a 25 years warranty for PV production. And the dual boost, so the increasing of the PV efficiency, so more electricity, is about 5 to 15% per year, thanks to the cooling. Thanks to SunHorizon, we also improved our research and development and innovation, and we developed some dual quick fit. You can see on the top left, to connect all the heat exchanger, all the panels on the back. The goal was to be, it has to be easy for the installers and quick, of course. So we have the dual quick fit now to connect as easily as the photovoltaic part, all the panels. We have a certificate made in France, and of course we have some PV panels also to complete the installations. So we have the spring, which is the hybrid panels, and the flash, which is the PV panel, because we size the spring panel with the hot water needs. And then if you have more space on the roof, you can add some PV panel. So now the company has 10 years this year. We raised 3.2 million euros and invest 2 million in research and development. And we were the best clean tech. We had the best clean tech growth according to Deloitte Fast 50 in 3 years, so 2016 to 2019, 500% growth. So now we are the world leader in PVT manufacturing. And our goal is really, and thanks to this project, European project like SunHorizon, our goal is to reduce the energy consumption of the buildings and of course the carbon footprints.
Sorry, Jean Marie, we cannot hear you very well. I don't know, maybe your microphone, if you can check it.
Since the beginning or just now?
Now it seems better. No, just now in the last 30 seconds. Now it seems better. Okay,
great. So we are the world leader in PVT manufacturing, and we just got the very great label in France, which is Industry of the Future. So because we developed a whole specific production line to build these PVT panels, so that's still good and positive for the future. So we have some installation in different countries. We have installation in 4 continents and almost 20 countries. So in Europe, in Asia, in Oceania, and in America. And our PVT panels can be used for preheating tap water, for example, to preheat pools, or as we will see in SunHorizon, and as you already heard, to be coupled with ground source heat pump also. So I will show you some examples of our different projects. So for example, the preheating of domestic hot water. It's a project in France, so collective housing, and you can see that it's like a standard solar thermal project. We preheat a solar tank to avoid to use the gas burner. In this project, you have a cost of the solar energy during 20 years of 10 euro cents per kilowatt hour. So that's pretty good because in France, well, the price is around 16 cents per kilowatt hour. So that's innovative, and you can reduce your bills. So that's a good point. And you can also improve the global efficiency of the system by doing not only domestic hot water but also space heating with some ground source heat pump. So we can see an example in Carquefou in France for a high school. It's a positive building. You have from one side you have 90 panels connected to a heat pump for domestic hot water, and you have 520 other panels connected to a ground source heat pump without boreholes, just with our panels as a cold source to bring the space heating of the building. So here you can see that we have an average cost of 9 cents per kilowatt hour. So that's still great, below the price of the customer. And also with what is important is the renewable coverage. You can see that we have, as we are the cold source of the heat pump, so the evaporator side, we have more than 80% of renewable energy, and the other is the electrical consumption of the heat pump, but we also produce PV. So our PV, 20% of the PV production is directly self-consumed by the heat pump. So that's still better than 80%. So it's really low carbon and low energy consumption system. Here is another example in the Netherlands for a student house with 303 DualSun panels. The goal here was to reduce the gas boiler consumption with a heat pump and our panels. And we produce around less than 500 megawatts hour a year, just with the thermal side of our panel and the heat pump. And of course, you can add the PV production, which is 77 megawatt hour per year. So you can see that this system, when you couple PVT panels to heat pump, you will bring way more energy thanks to the roof. And that's the focus of SunHorizon project. Here is the four projects where our panels will be installed in the SunHorizon pilots. So I won't detail everything because it was already done, but it's a collective housing in Nuremberg and Madrid, and a swimming pool in Verviers with boosted heat pump, and some houses in Riga, also with boosted, and in Madrid is with the BDR Tamea heat pump. So for PVT, this is the future to be coupled with ground source heat pump because it's cheap, easy to install because you don't have to make any boreholes. And as people want some energy on their roof, PV panels, it's a shame to not use all the heat you can recover from the PV and from the roof. And we will demonstrate, I'm sure, with SunHorizon that it's a very low carbon and low energy solution to associate heat pump and PVT. Well, thank you, and don't hesitate if you have any questions.
Thank you, Jean Marie, for your presentation. Now we can, I see here that you put your email, so if any of the attendees would like to maybe ask you some more details, they can directly contact you. Now we can proceed with the second presentation of the second solar technologies involved in SunHorizon project. So Guglielmo.
Yes, hello. I hope you can hear me well enough.
Yes, we can hear you, and now you have also the control. So the floor is yours.
Of the mouse. Thank you very much. And hello, everyone. Thank you for inviting me. I'm here to introduce TVP Solar as a technology provider in the SunHorizon project. We are manufacturers of high vacuum flat panels. This is a new generation of solar thermal panels that will be used in three different demos within SunHorizon. I'm going to show you a bit why and how we are going to profit of this experience to promote the use of solar thermal in energy, in renewable energy utilization for buildings and the decarbonization of building systems. So first of all, just a quick introduction. TVP Solar was founded 12 years ago in 2008. During these 12 years, we have invested more than $70 million in the development of this breakthrough technology, the high vacuum flat collector. And we have built a factory. So this product, in at least one of its versions, is already in mass production. And I'm talking about the medium temperature collector that can achieve operating temperature up to 180 degrees and has been thought and designed for medium and large scale application. For medium scale, we intend in the hundreds of kilowatt range, and the large scale from the megawatt to tens of megawatts. So our aim with this new product is to replicate the success of PV products in electricity, also in the thermal utilization, and to decarbonize thermal use both in industry and in civil buildings. Just moving on. Sorry, I moved on too much. Okay, so quickly, what are the innovations that we brought to solar thermal? So first of all, this is a high vacuum flat box. This is, I guess, first of its kind. You know that high vacuum has been used already in solar thermal to reduce thermal losses towards the environment, but in tubular forms. High vacuum flat panels have different features and some advantages compared with the tubular collectors. First of all, we reduce a lot the thermal losses outside the collector as well as inside the collector. So basically, we'll be able to use lower surface in order to achieve high energy yield. And to be very clear, the main advantages are its versatility and simplicity of use. So we really pointed at using the collector in several different climate ranges, from low to medium radiance to high radiance. In fact, the advantage of a flat collector is to collect light from any possible direction. So I would say that also with diffuse light, such as in cities, in foggy or cloudy climate, our collector is able to deliver the required temperature whenever even a small amount of solar irradiance is available. And second, versatility is about the temperature range. So today, when we say that this is the world's best solar thermal collector, we mean that certified data show that this is the best thermal collector. Let me show you just quickly this concept with these beautiful graphs. I mean, who doesn't love a graph? I don't want to insist too much on numbers, but just to show you the comparison of the performance of a high vacuum flat plates with existing solar thermal collectors. These are all curves derived by certified data. On the y-axis, you see the efficiency, that is, meaning the energy yield per square meter of a collector, and on the x-axis, you have the temperature, the operating temperature of the collector. So you see that there is already a wide gap above 60 degrees with all existing technology, both the flat plates and the vacuum tubes, as well as CPC collectors. So basically, this situation is not very common. So when I'm saying full sun, I mean 1,000 watts per square meter of irradiance. This is true only when you have a very clear sky in a beautiful summer day. But in reality, especially at our latitudes, and this is the case of SunHorizon demonstrations, in Europe, for example, the typical case is that the irradiance is much less, and it's not direct, so the sky is not clean. So at this point, you see the real advantage of having high vacuum in a flat box. So basically, you see that traditional solar thermal collector cannot remotely produce the amount of energy that a flat box, a high vacuum flat panel can produce. So in this case, you see in the curves at 500 watts per square meter. That is why over the year, it's important to calculate all the energy production, and not just at the peak. And we can provide meaningful energy delivery all year round, and also in low irradiance places. And in fact, we have said already that SunHorizon project has several demonstrations in low irradiance areas. When we say Germany or Belgium, we're talking about really mid to low irradiance places. In Spain, situation is better, and in fact, we will go for a different kind of setup. So our system is not only the collector, but it's a whole setup that is dedicated to solar fields rather than just the collector. And our concept is to see the solar field as a solar boiler, basically, in which you can set up the temperature and obtain that temperature with consistency and with stability over the day, over the months, over the year. So at this point, the integration with other technologies, as we have already seen and described, is in fact the possibility for the overall control system that is going to be designed and is being designed under the SunHorizon project to be able to provide to the solar system a temperature set point. And then we can provide them with a stable and reliable supply of energy at the required temperature. So what you're seeing here, for example, in the picture, is a solar field which we have deployed in Kuwait City, and it's dedicated only to solar cooling, so using an absorption chiller, which is different from the one that we are going to use in SunHorizon, dedicated to an office building. So this is a typical situation like the ones we would like to see in the SunHorizon project. And in this particular case, the absorption chiller is a double stage one. So we operate this solar field consistently at 160 degrees over the year. of course, in Europe to achieve such high temperature is not so easy, and we will operate single-stage adsorption chillers that will need only 90 degrees. Let me go. So in fact, the number of applications, and here is the versatility that we are targeting, is quite wide. So from solar district heating and cooling to industrial process heat to some important oil processing processes in oil and gas industry, as well as air conditioning and cooling. So all of these have different temperatures and features, but we are already demonstrating, at least with our current version, the empty power, these applications around the world. I mean, recently we are building 2 solar fields in Europe, for example, for steam application, for hot water application in the south of France and in Italy. And we are building district heating applications at 90 degrees or 100 degrees in Switzerland and in Italy as well, and also in France. So this is something that is happening right now. So the SunHorizon project will help us, and already has helped us, to improve the features of the collectors for specifically lower temperature applications. So lower for us, but still very high temperature for a solar thermal system. So in particular, this is a kind of application that is a dual application, in which during winter we would provide hot water for the heating network as well as domestic hot water for civil use, while in the summer we could raise the temperature of the solar field and provide sufficient energy and temperature to with a good efficiency and with high energy yield to be dedicated to the chiller and to the cooling network. So this is a schematics that shows the versatility. Now, of course, so far we have been using the certified collector empty power that can reach 180 degrees. One of the activities that we have developed in SunHorizon is trying to reduce cost of the collector by implementing several solutions like the ones that Andrea has quickly shown you, both at the panel level as well as the balance of system level. Of course, delivering 90 degrees is not the same as delivering 180. So there is a sort of downgrading of some components that can achieve cost cutting, but not compromising on the efficiency. So these are I won't stop too much in this particular description because we already went through in the previous presentation. In Sant Cugat, this is a very interesting setup because we will have exactly the dual use that we have been talking about. So the summer cooling combined with the winter heating. And in this case, this is for us, it's a small installation, but still meaningful because it could be quite replicable all over Europe to properly use a rooftop in order to provide with solar thermal energy, which is going to be used year round. You know, what is the issue with the solar thermal energy? That you have heat mostly when you don't need it, so during the summer. So with this setup, we really want to show that both in winter and during the summer, we can use properly the solar thermal energy at high efficiency and with good impact on the energy and emission level of a building. So this is what I just described. So the issue is to provide stable amount of energy, and in order for you to properly understand what is the advantage, I want to tell you that to provide 60-70 degrees during the winter in any location with the solar thermal is something that you can only do with our collectors, because what I just shown you, even with a low irradiance level, the efficiency of the collector is still very good, above 60%. And the second meaningful demo that we believe will show all what we're saying is in Verviers, is in Belgium, so low irradiance place to produce heating during the winter. I really hope that the extension of this project to solar cooling during the summer can be done even if outside the SunHorizon project. I'm not going through this. So I hope I stayed in the given time. Thank you very much. I'm waiting for your questions. Thank you.
Thank you, Guglielmo. Thank you. So we can now proceed with the presentations from the external speakers, so people who are not in SunHorizon project, but they kindly accepted our invite to give a presentation today. We can now start with Pedro Dias from Solar Heat Europe, who will give us a presentation about the RINA policy related to the solar sector. Hello.
Hello.
Pedro.
Hello, good morning. Thank you for the invitation.
Thank you for attending. I give you the control.
Okay, very good. So it's a pleasure to hear about the project. I've seen before and visit the website, and I'm very happy to see some of the information and looking forward for the additional results. So we were asked to talk about policy insights on research and innovation regarding solar heating and cooling. We will do so. I will start with just a very quick overview on some aspects on solar thermal markets. Then we will see a bit of framework for the discussions on renewability and cooling research topics, proposals that have been ongoing, and then looking a bit into the future, and finalizing with some ideas on some challenges. So starting with the questions on the market. So to give you a brief overview, so we are talking about capacity installed in Europe of 36 gigawatts for over 25 terawatt hours of energy generation. But we want to point out that we are talking about 180 gigawatt hours of storage capacity, so thermal energy storage. So as you know, solar thermal is always, systems are always installed with storage capacity. And this is quite important, in particular when we look into other characteristics and comparison of prices and so on. We need to take into account that this is already reflecting storage, which is quite an important added value on these systems. So the market had faced some challenging periods. It's still challenging, though the last 2 years have been positive for solar thermal, with different trends in the markets. I will not get into details on that, but we had 2 years with positive market development. So here you see on the left an overview of the total installed capacity of solar thermal in the market. So the blue bars, being that the light blue is the latest additions. So I know that not all technologies do that, but we take into account the replacements. So not everything that is sold in 1 year is added to the installed capacity, because as we are in the market for, we have solar thermal systems in the market for several decades, older systems, usually over 20 years old, are taken from the statistical purposes, taking away from the numbers. So that's why we always make this distinction between what is newly installed and what was already existing on a yearly basis. And on the yellow line, you see the evolution of the market. So that was for 2018, where we were about 8% positive. 2019, the growth year on year is a bit lower, but is still on the positive side. Then we look in solar thermal overall at the global level. So we see there a comparison between different technologies. So you see there solar thermal on the left side. In blue is the capacity operation. In reddish, let's say, is the energy supplied. So you also see the comparison with total capacities for wind, for photovoltaic, and then for geothermal and solar thermal. We are missing other renewables, but these are what I usually refer to modern renewables. But of course, there is also a huge capacity in hydro and in biomass. So overall, in Europe, we are in terms of energy produced at 26 terawatt, as mentioned. Worldwide at 389. In installed capacity, you can also see that Europe represents less than 10%. The biggest player worldwide is China. So thermal is quite diverse. So usually seen in relation to the residential applications, but it also covers commercial services, and it's not referred there, but also solar heating and cooling. This was also referred in the session today. Actually, the example in the building that is shown with commercial services is a combined, so it's solar heating and cooling system. But then also very large systems for district heating or for industrial process heat. So just to give you an example of what does it mean in terms of largest systems in Europe, just to have an idea of how large solar thermal systems can be. So on the right, we see for solar district heating, 110 megawatts thermal of installed capacity. So for the 8 gigawatt hour a year heat generation for district heating, we see on the left a project that should be finalized soon, which is for industry and will be the largest in Europe for industry. In 12 megawatt hours with 8 gigawatt of heat supply for a molting process. But this has been growing. The size is also growing in the number of solar heat for industrial processes plants around Europe. Another aspect which is important, which is in terms of trade balance. So as you know, not all technologies have a positive balance when we think of in European terms. So solar thermal is one with the biggest net exports. So we are talking in general of a balance of around 1 billion net exports, and is also one of the renewables performing better in the European context. Another aspect, so in terms of an assessment done between IRENA, the International Renewable Energy Agency, and the European Commission. So this was looking into enhanced ambition in terms of renewable targets, and what will be the technologies that could deliver more. So you can see how much they can contribute in terms of the percentage, in terms of the increased proportion or percentage of contribution for the renewable targets. And here the substitution costs. So you see that most renewables have negative substitution costs, which is quite positive. So the one with the lowest or the best performance in this case is solar PV, right? Followed very, very closely by solar thermal in buildings. And we also have solar thermal in industry included with a smaller potential in terms of overall percentage, but still quite important because it's side by side with bio energy for industry, geothermal for industry, and so on, and even showing better than heat pumps for buildings, for instance. Continuing, so yeah, so these were the highlights. You know, there is a huge challenge. I think you're all aware of that. There is a huge focus on electricity. What is usually not so clear is that the overall contribution of renewable heat is higher in absolute terms than of renewable electricity. And you see that here. So while renewable electricity represents 29.6 of the total electricity demands, which you can see here, and renewable heating and cooling is only 19% of the total heating and cooling demands, because the heating and cooling demand is so much bigger, is the double of the power demands, the absolute contribution is higher. So there is a dissonance between the political priorities, also in terms of research and innovation, and the reality and the potential in the market. It's shocking, but it's indeed what is happening. So, and what we see at the same time is that there is a lot to do in terms of increasing the percentage of res on electricity. At the same time, we want to cover more transport with renewable electricity, but we also hear about talking of electrification of heating at the same time. So we think that there is the need for additional renewable electricity in the system, that is clear, but we should also focus on who is already providing renewable heat as a source, as a priority to cover renewable heat, even if we will see also later we need to address sector coupling in a sustainable and consistent way. Another one of the aspects is that the heating sector is quite complex. I will not go too much on this, but we are talking about very different definitions of heating and cooling. So when we talk about heating and cooling, we take into account what are the sources, the form of energy, the enablers, so the technologies, the type of consumers, and the type of use that is done. And this is, when we're having discussions, it's not simple to bring detail, because sometimes to bring more detail seems that we are adding complexity to discussion, and often people like simplified messages and not to make them more complex. So that's one of the challenges we have on heating and cooling, is to try to address it in a clearer way. There is better awareness now, but there's still a long way to go. There is clearly an importance of looking into what is the energy system in the future, and this we want to point out mainly that there is a role for all technologies, and there is a role for integration between power, between thermal sources. So all of these can be combined in different ways to play an important role in the heating system, and it needs to be seen in a combined way. So trying to simplify, we see reporting to the complexity we spoke before. We're talking about the importance of energy transition in terms of demand and supply. We're talking about buildings and industry. Buildings, we're talking about individual and district heating. Industry, we're talking about industrial plants. Industry and district heating, they deal with larger investments. So they have specific needs in terms of research, in terms of financing. So they have different market barriers. Individual systems or collective systems in multi-family houses have also the difficulties which relate to the relatively small size. So we're talking about the need for aggregation of projects, but we also needed talking about a more strategic approach and working with consumers on what is called a planned replacement, so that when a change is done, it is not done because it's an emergency and therefore going for the already existing solution or similar to the existing solution, but we can really change to something cleaner, more sustainable, but that requires a planned replacement. Coming to the topics on research, it is essential to point out that the main player when we talk about research and innovation on renewability and cooling is the renewability and cooling ETIP, so European Technology and Innovation Platform. This is quite a unique platform because it combines the different technologies. So sometimes this is a strength, some other times it's it might be an handicap because we look at the technologies together, rather the platforms look at the technology specifically. But in this platform, we try to address these by a matrix approach. So we have on one side the technology panels, so thermal biomass, geothermal, heat pumps, and district heating and thermal energy storage. And then we have the horizontal working groups focused on the demand side, let's say. So what are the solutions we need to provide for buildings, industry, cities, and districts, combining the different technologies. So for those of you that are not aware, we invite you to look into the renewability and cooling technology platform. And thinking about priorities and setting priorities, this is a critical moment. So the RHE TIP Strategic Research and Innovation Agenda is under consultation. So the phase for inputs closed last week, if I'm not wrong, or beginning of this week, and we have a webinar next week, Tuesday. So you can subscribe. So you can go to the RHE TIP websites and see more information about this, or you can contact us and we can forward this information to you. So there is opportunity also to have a voice in terms of the SREA for the renewable cooling sector. Furthermore, there will be coming soon in October the annual conference of the platform. So I'll give you a quick insight. Of course, this was going to be online. We also have more information on the website of the platform. So solar thermal, in terms of research and innovation, what was done so far? So the last period was focused on the last framework program, so Horizon 2020, and our strategic research and innovation agenda at the time, and in particular the roadmap that was developed afterwards, was very much focusing on 2020, and this was a request from the Commission to focus really on deliverables by 2020, considering the demand in terms of targets and so on, and the need to bring quick solutions to the market. So that implied making some choices. So if you see the SREA, there were other important questions, solar cooling, for instance. In this case, the roadmap had to focus on three main aspects: large solar scale, large scale solar thermal, solar active house, and solar compact hybrid systems. I give you some very quickly some examples of some projects that have been supported in relation to these different priorities, but we are not satisfied. So the number of calls that were specific on these different topics was insufficient, and also the budget allocation and the number of projects supported was also insufficient. So the result of this was that there was a very low rate of success. So we had in solar thermal projects 10, 15 to 1 in terms of projects applying and projects supported. This is above average comparing with other calls. So it also shows that there is a need to increase the number of calls and allocated funding for this sector. It will also be interesting, but we don't have that data, and the Commission doesn't make that data available, which will be also to know what was the ratings, for instance, of the projects. So projects that were approved for different goals, what was their overall rating? Because we have seen solar thermal projects with very, very high evaluations that have been out. So this also attests to the quality of the project proposals and to the competition which exists, because there is an interest, but there is a limited number of calls compared to the needs and to the potential. So, as I mentioned, the strategic research innovation agenda of the platform is being developed. It's under discussion. More specifically, looking to Horizon Europe, I can share with you very briefly some of the recommendations. So, and then I'll go more details on some what we call the some industrial challenges. So I will try to give a general overview of what this means. We think that one of the difficulties in the Horizon 2020 was a mix of calls that were addressing renewables, but this means that it was mixing renewable electricity and renewable heating and cooling. And we think there is a bias towards renewable electricity. So there are more experts with a better understanding of renewable electricity. There is politically also, and media and so on, much more notoriety to renewable electricity, and in our view, this has been penalizing the renewable heat. So it's important that the calls could split between renewable electricity and renewable heat and cooling. In some cases, dedicated proposals for specific technologies are important, but even when they are multi-technology, open to different technologies, at least that they separate between electricity and heat. And just to give you an example of some of the issues. So when a renewable electricity solution is comparing CO2 savings, which you know is one of the criteria requested, they compare with the electricity mix, which in some EU countries is extremely high, CO2 content on electricity. For renewable heat, often it is a comparison with gas, which has a natural gas, which has a lower CO2 content. So immediately there is already a difference, a bias that will give an advantage to renewable electricity. So they are different solutions. They are both needed, but they should be dealt separately. Even if sector coupling is important, and the combination of the two should be seen, but that in the context of sector coupling. So there should be also additional topics which look into this more energy system approach. Then Horizon Europe has also an issue in terms of TRL. So we missed in Horizon Europe, on Horizon 2020, we missed higher TRLs. Also, the market uptake, they try to improve and include towards the end some more market uptake calls. But again, these were this kind of calls where every technology could apply with the limitations I just mentioned. So this is an issue. It should have a better reflection in terms of TRLs and covering also a broader scope from lower to high TRLs. And then some specific things on solar heating and cooling. So we face challenges, for instance, in terms of the high number of demonstration projects when we talk about solar heat for industrial processes, for instance, because supplying heat to, let's say, a paper mill is different from a malting processing factory, because temperature ranges might be different, flows, pressures, the other requirements. So it requires much more demonstration because the demand side, it's also much more diverse in terms of the needs. So that means that the fact that there is one demonstration on a paper mill will not mean much to the brewery that is that has a plant next door to this paper mill, because they are essentially different. And then the fact that we are also looking into solutions towards the market, like for industry, so district heating or buildings and so on, does not mean that we don't need lower TRLs. And I wanted to stress these because of the choices on the roadmap, as I mentioned, because on the roadmap and the focus on 2020 meant we had to give away the focus on lower TRLs, and that is quite important. So there is also the need to bring additional work on materials, on collectors, different types of collectors, storage materials, solar cooling, and so on. And I am quite extensive, so I think we are limited on time. I will just give you, I will not go into the detail on the rest of the slides on the industrial challenges, but just to mention, some of the challenges in the market which are also relevant for solar thermal, and solar thermal as an answer to them, but also needs additional focus and research and innovation. We're talking about topics related to scalability, smartness, hybrid solutions, of which SunHorizon is a very good example. Sector coupling, likewise, even this is more of a system level, but still, or thermal energy storage, building integration, competitiveness, so reducing costs or increasing performance and so on. All these different topics are also current challenges for the market, in particular for heating and cooling, which are also important to address and to have room for the potential that solar thermal has in these areas to be unleashed. So that's it for the moment. Thank you very much, and I'll be happy to answer questions later.
Thank you, Pedro. Thank you very much for your presentation. We can now proceed with the presentation from Daniel.
Hello, Daniel Mugnier speaking.
Hello, Daniel.
So
I'm giving you now the control. Please.
Okay. Okay, thank you. Perfect. So I'm Daniel Mugnier. I hope you hear me well. I am speaking you on behalf today of my position of chairman of the Solar Heating and Cooling program, which is dedicated to innovation on solar thermal especially. And my specific topic, I will try to do fast, but directly to the topic of cooling, solar cooling, PV and thermal cooling. So maybe first of all, important just to give you one short description of what is Solar Heating and Cooling program. It's a part of the IEA International Energy Agency group dedicated to push for innovation in that field, solar. And we have the really big advantage to represent nearly all worldwide. You see in this map, our members, nearly 20 members, are based in the different continents. And we have now even a very interesting aspect. We have new sponsors, you see, especially located in Africa, which permits really now to target much wider territory where solar energy is particularly accurate. So that's really the first aspect. And now I will little bit more describe what is really the challenge about cooling and how solar cooling can be a very good player. You know all that, and it was already detailed and described by the person from TVP Solar. There is a really good adequation between solar resource and cooling demand. You see this graph, basic graph. I won't spend too much time on it. But then the very important aspect is the situation worldwide now. It's particular in Europe, but it's even more intensive outside of Europe. You see first that IEA in a recent time published a very interesting document called Future of Cooling, saying that between these last years and 2050, there should be more or less a triplement of the cooling demand worldwide, especially mainly driven by residential sector. So you see it's huge numbers, and it's even the biggest growth for building sector worldwide for the next decade. Second, of course, cooling is going to boom in emerging economies. So this is really one key aspect I wanted to transmit you. SunHorizon is focusing on Europe. It's financed by Europe, and it's really good. There is a lot of innovation coming from Europe. But the cooling market is in Europe, but especially out of Europe. And there is a really interesting aspect about preparing solutions inside Europe, covering, addressing the European market, but then being very much ambitious and go beyond and address countries outside of Europe. Regarding to that as well, yeah, you see other facts and figures. Single largest user of electricity in buildings, cooling, and there will be a very huge electricity demand increase everywhere. So as soon as you say that, there is an absolute need in the very near future to be able to avoid this important electricity demand worldwide, which create a lot of problem, we know, of congestion of networks. So there are then several solutions based on solar, which permits to go on that way. Just one last picture showing you graphically this huge boom and you see here the reference of the publication itself. So I'm a little bit fast. How can be the solar cooling contribution? On this, it was my purpose. There are two channels, and that's really interesting because SunHorizon is, let's say, more or less covering these two aspects. There can be a PV cooling approach where electricity from PV can contribute to feed air conditioners or reversible heat pumps. And of course, there is a second channel using solar thermal cooling, renewable heat, being used to feed chillers. You have an example with Fahrenheit, or there can be example with Yazaki and other technologies to create chilled water and then cooling. So if you have these two solutions, I think as former manager of several work and projects on solar cooling, I think it's totally not interesting to put them totally into opposition, but much more to define and see where one is more interesting than another one. And there will be probably a so big market about cooling in the world that the two systems will perfectly coexist and develop. The space is very large. Now about what is existing worldwide at the moment, the latest figures are showing that there are very few solar cooling systems worldwide. We see less than 2,000 units in the world. You see again that they are concentrated mostly around the tropics, where of course the cooling demand is important, but with a particular focus, Europe is quite developed as well. Historically, we have a real experience and know-how and manufacturers, Fahrenheit being an example again, but others in the side of collector manufacturers, capable to build, design, and let's say make work such systems. But just one figure in comparison. At the moment, worldwide, there are nearly 110 million units of air conditioning sold yearly. So this market is absolutely ridiculous at the moment compared to the massive conventional electric-driven market. So there is, by this way, it's really early ages, and there is really a need of proof of reliable, cost-competitive solutions in Europe and beyond Europe. And that's why I wanted to introduce for the end of my presentation, reminding that, of course, you are you have the chance, thanks to SunHorizon, to prepare such solutions for the European market. And I show here the different solutions which are at the moment under development. But it's a perfect lab for SunHorizon to prepare solution which could then be exported outside of Europe. And now I wanted to introduce the last important info I wanted to transmit to you. It's a new project driven by our program dedicated to work on solar cooling for Sunbelt regions. And you see here the zone concerned by this program and this group of researchers. You see that southern part of Europe is concerned, is included with Spain, Portugal, Italy, and so on. And the goal is really to focus on innovative and affordable, safe and reliable solar cooling systems for the Sunbelt regions worldwide. And there is a very interesting work based on the international collaboration to adapt existing technologies or under development technologies for this huge market. And it's totally agnostic. It will be both using or using solar thermal and solar PV. And it's based on a lot of, let's say, very interesting accumulated work done in the past tasks, which means project in our group, 25, 38, 48, and 53. The target segment is between 2 kilowatt and 5 megawatt. And the big chance is it has just started in July. You will just see that it's composed of 4, let's say, subgroups: adaptation, demonstration, assessment and tools, and dissemination. You see here the leaders, and of course you can recognize that some of them, especially in subtask A, are not far from the SunHorizon project. It's mainly, let's say, managed at the moment by European entities. You see Italy, Austria, and Germany, but it's at the moment opening a lot to territories and countries out of Europe. You see that there are there are several tens of interested bodies for this project. You see a lot of letter of support and interest. So we are just starting, but we are still open to newcomers. The kickoff meeting will start at this date. You see, 28th and 29th of September. And we have the big support of Mission Innovation. And I really invite you, if you are interested in joining and to see the rules to join such an initiative, to contact Yuli Jacob from, you see the email address on this slide, from Dr. Jacob Energy Research. So, you have a lot of information on this website. Just Google task 65, sorry, and you will find a lot of information. So just to conclude, this is part, this task of what is at the moment ongoing. And you see a task is specifically focusing on solar process heat, which was marvelously detailed by Pedro just before this topic. And again, I give you the address in this slide of our task on solar cooling. So I hope I was short enough, being the last. Just one bullet, it was that just recently, SunHorizon was awarded by IEA to figure inside the selected project in the initiative Today in the Lab, Tomorrow in the Energy. So this was really a nice recognition about the quality of this project to be communicated at IEA webpage and IEA headquarter level. So thank you very much for your attendance and especially for attending my presentation. You have my contact data as well. Yes, the floor is now back to Serena.
Thank you very much, Daniel, for your presentation and for being our guest here today. We can now officially start the Q&A session. So I have a first question for Pedro. that is, what do you see as the main barrier today on policy level for the solar thermal market? I have to, just a second, I need to unmute Pedro. Okay, here.
Okay, I think I was trying to unmute myself and you were trying to do the same and we were canceling each other. Okay, so thanks for the question. So we try to address some of those aspects. So one of the questions is related to renewable heat overall and the perception of renewable heat. I give an example. The SET plan, which is the Sustainable Energy Technologies, Strategic Energy Technologies plan, was created in a way that it addresses all renewable electricity solutions, wind, PV, ocean, concentrated solar power, and so on, and did not cover any of the heating solutions. So the heating solutions were supposed to be addressed under general, let's say, more general priorities on buildings or industry and so on. That is an example, and we had many discussions from the platform, from the different associations, with the Commission trying to alert them to this issue, and the answers were very frustrating. We're saying, yeah, indeed, there is a gap there, but nothing we can do about it now. It's done. So when the Strategic Energy Technologies plan is reflecting on additional initiatives and cooperation between member states in terms of research and innovation, but also on the design of other initiatives, partnerships, and even on the program, so Horizon 2020 and likely Horizon Europe. So there is a major challenge, which is to still continue to make people aware of the size, of the relevance, and of the potential of renewable heat. Here, the challenge is that there are very big players and stronger in terms of their capacity. When we talk about the power sector, renewable or non-renewable, because as you know, mostly is non-renewable, and they have a huge capacity, lobby capacity. But also on other issues like hydrogen or renewable gases, which I will not comment if these are, what do this mean in terms of solutions, because there are different opinions and different studies which go in different directions. But what we want to stress is that we cannot put too many eggs in one basket. So we need to consider the different solutions and the ones that are already providing results, and that are mainly European technologies. In renewable heat, that is very much the case, and in solar thermal, that's even more. So that is one major difficulty, because the rest cascades from there. So with the difficulty of creating a dedicated attention for and space for renewable for research and innovation for renewable heat, it will make always this competition with the other solutions from electricity hard and difficult for the assessment and to compare potential results and so on. Then there is the question of the complexity of the market. So we had mentioned, I had in the presentation one point on scalability, so the importance of going, the potential also regarding large systems on the industry and so on. So heat for industry, so district heating, which we see developing, but not as fast as it could, if there was the adequate investments. But there are there is also the fact that heating and cooling being decentralized, being mostly a local reality and dealing many times with small systems, faces a different challenge in terms of finding the solutions through the policy discussions. So just to give you an example, when we're talking about converting a neighborhood, that's a priority. That can be a priority for a municipality, but that will be one into many topics when it comes to national priorities for development or research and so on. When you talk about large things, I don't want to always talk about hydrogen, but let's use that because it's a common one now. When you talk about hydrogen, it's a huge investment that has to have a national attention and very strong national players. So these divides between the priorities which are local and a bit more distant from capital cities and from Brussels, in comparison with those that are so large that they really catch the attention at these higher levels of policy making. Because in terms of identification of topics, there are enough areas for development. The technology is still present in the market, is still competing at some very rough years. Situation is still hard, which means that companies or manufacturers are also more limited resources to apply for research, which is one of the difficulties. But it's mainly the question of the political priorities and the balance between the different political priorities.
Okay, thank you, Pedro. Now, I have, let's say, more a comment than a question for Daniel. So a comment for one of the participants saying that we should also consider geothermal cooling and solar cooling. What do you think? If you want to comment on that, Daniel.
Yes, yeah, this is really interesting on the principle. The limitation being, if we speak about geothermal cooling, it could be is it to improve the efficiency of the solar cooling, let's say, device itself, or is it to work in parallel? Because one main concern when we mix these two approaches is that it's creating quite important overcosts. So that could be in a way a very, let's say, performing solution, because permitting to reach very, very high level of, let's say, penetration of renewables for cooling. But at the same time, these are not, very low cost or low capex technologies. So each of them can be really suitable, but when they are together, this could create important consequences. But just saying that, it should be interesting to have maybe more details about the technology to discuss with this question and this person.
Yes, thank you. Indeed, as you see in many presentations, you will find the last slide, the email of the speaker. So if you want to better engage privately and propose your question or to talk with them, you can send them an email. I know that they are happy to continue the discussion further. We can proceed with the last question since we are running late of 3 minutes. This question is for David. So, David, you showed a large amount of fuel and GHG savings. Could you please say a word on investment needed and the payback period?
So at this stage, this aspect of the costs was not investigated a lot because the question of the capex is covered by the project in SunHorizon. So the objectives was mainly to increase as much solar energy as possible in the available free area of the demo sites. So we calculated of course the invest costs and operation costs as well for each of the demo sites, and but we were using let's say prototypes cost and not market directly market or foreseen market costs. So we end up with relatively high capex for most of the demo sites, and quite high payback time above 10 years for most of the technologies because we were using quite high costs as assumptions. So I think this aspect will be reworked later on in the project in the work package 7 with more detailed assumption regarding the cost, also regarding the evolution of the cost of the energies, the fuel energies. What we investigated also is about the cost of the carbon, and we calculated sometimes also the equivalent cost of carbon that we would need in order to cover the in order to move the payback time to 10 years. Yes. So these are okay.
Yes, indeed, about maybe the payback and other details will be maybe presented in the next stakeholder workshop that will be in around 8 months, where we will have also more results, let's say, from our demo sites. So I'm going to close here this workshop, since we are 6 minutes late, but I think we really had some interesting presentations, both for SunHorizon partners and also from our external speakers, Pedro and Daniel. Thank you again really for accepting our invitation and being here today. As I said at the beginning of the workshop, tomorrow you will receive via email all the presentations and the video of this recorded session. So if you want to go through the PowerPoint again, and then if you have other questions that unfortunately we weren't able to answer to all of them now, you can send an email to the speaker. Thank you again also to the participants for staying here with us 2 hours to this workshop. And see you soon. Thank you. Bye-bye. Have a nice day.